Flack math! Give me some math and I'll give you some flack. Flack math!
So we're going to talk about types of parallelograms. So can somebody tell me 3 types of parallelograms?
Square.
Okay, that's one.
Circle.
No.
Wow.
A rectangle? Oh, wait.
Rectangle.
A rhombus?
And a rhombus. So those are 3. Rectangle is just a specific type of parallelogram, just with right angles, right?
So
But it's still a parallelogram. Okay, so lesson 61, we presented several methods for determining if a quadrilateral is a parallelogram. So now the properties, we're gonna be specific. So if an angle in a parallelogram is a right angle, if just one angle in a parallelogram is a right angle, and it's a parallelogram, then all of them have to be right angles, which makes it a what?
Square.
Rectangle.
Rectangle, but maybe a square, but not necessarily.
Is that like a square just a specific?
So here's props of parallelograms. If one angle and only one in a parallelogram is right, then this sucker is a rectangle. Okay, you can do that. It's not good grammar, but if one angle, just one, in a parallelogram is a right angle, then it's a rectangle. Okay, so that's one property. So here's another one. If consecutive sides of a parallelogram are congruent, then it's what?
What was it again?
If consecutive sides.
Oh, it's a square.
Could be.
Or or a rhombus because they're all the.
So a square is just a specific type of rhombus.
Yeah.
But given this if, the information in the if, the only thing we can say is that it's a rhombus. It could be a square, but we know that for sure it's a rhombus. If two consecutive sides in a parallelogram are congruent, then it's a rhombus. Good. So I feel like you guys are seeing it a little more before I draw it. But if I were to draw it, so if you know that this one's right, well, in a parallelogram, you know that opposite angles are congruent, so you know that this is right. And also the properties of the parallelogram say that consecutive angles are supplementary. They have to add up to 180. So what adds to 90 to get 180? Another 90. So you can say that it's a rectangle. Over here, if two consecutive sides are congruent, well, you also know that opposite sides of a parallelogram are congruent. So you know that those two are congruent too. So they're all the same. So this is an equilateral parallelogram, which is a rhombus. Okay. So they're in lesson 65. It proves that for you, but let's do this. Okay, so I'm going to go. So if diagonals of parallelogram are congruent, then it's a rectangle. So this is the third property. If diagonals of parallelogram are congruent, then it's a rectangle. Okay, so here's a parallelogram. If these guys are the same, then it's a rectangle. The only time they're not the same is when it's not. So see how this one is shorter than that one. The one that goes down to the right is shorter than the one that goes up and to the right. It's longer. So it can the diagonals are only congruent if it's a rectangle. Okay? So far, so good. The 3 properties we've learned so far. Here's a 4th. If diagonals of parallelogram are perpendicular, so they form 90-degree angles, then what can you say? Can you picture that?
Wait,
So the
what?
diagonals aren't necessarily congruent like they are here, but they're perpendicular, which means they cross at 90 degrees. What can you say about that? It's a square is what you, it could be, doesn't have to be a square.
Oh, yeah, it could be a rhombus. Or it's using
It is a rhombus, but it could be a square. Yep, so rhombus, look at this. The only way they're perpendicular is when it's a rhombus. Look at this rhombus here. Okay, that's the only time that perpendiculars in a parallelogram or that diagonals in a
Diagonals have parallelogram or perpendicular.
is when it's a rhombus. Thank you, Tori. Okay. Does that feel all right so far? And these are like, just go with your gut. That's what we're doing anyway. All right, one more property and we're done with lesson 65. This is the last property. If a diagonal in a parallelogram bisects the opposite angles, then what happens? If diagonal singular of parallelogram bisects the opposite angle, then what is it? Okay, so let's look at this. Does this diagonal bisect that angle? Doesn't look like it. Looks like this angle is a little bit bigger than that, or a little bit smaller than this angle, right? What about here? Does this diagonal bisect that angle? Looks like it. So guess what it is? It's a rhombus. All right, and then there's proofs to go along with that, but we're going to skip those.
Yay.
I don't do proofs.
That's lesson 65. How's that feel? So you can use these properties in a proof, but you can also use these to help you answer questions. Like if this was x, and this is 50x minus 8, then you say, hey, wait, that doesn't help me at all. But if these are the same, because these aren't congruent, but the diagonals in a rectangle are congruent. So if this length was x and this length was 50x minus 8, you can set those equal to each other and figure out what x is, okay? Does it feel all right? All right, 66.
This sounds like a nationwide.
Yeah.
All right, perimeter and area. Again,
I kind of vibe with perimeter and area. I'm on
Me too. I like perimeter.
I kind of vibe with it.
Look how
And so
regular.
I was like, my kids, I know one vibe with them, but I forgot my last one.
Okay, so we are going to step this concept up a notch from your pre-algebra, algebra, all of those earlier days. We're going to figure out how to do something new that we haven't learned before. Well, how do you find perimeter again?
Add all the sides up.
Yeah, so if in a regular polygon, how do you find the perimeter? In a regular polygon. Okay, but what makes a regular polygon regular?
It's irregular.
Four sides.
All the sides are the same length. So you basically the number of sides times the length of one
So
side.
like 5 times 4.
Yeah. So if it was a square, it'd be 5 times 4. If it was a pentagon with all sides that were 4 inches long, then it would be 5 times 4 as well, because you're just multiplying the length of the side times the number of sides. So regular polygons have, we don't just know that they have the same sides and the same angles, but now we're going to discover some new things. Okay.
That was lesson 66.
No. All right. So now finding the area of a regular polygon is a little bit trickier. And we're going to use Pythagorean Theorem to figure it out, but here we go. So each regular polygon has a point within it that is equidistant. Okay? This is the center. Center of regular polygon. Okay, the center of a regular polygon, basically a point within it that is equidistant from all the vertices. Equidistant.
So it's basically like a diameter.
No, a diameter is a...
No, I mean radius.
Nope, a radius goes from the center to the side. So from vertices, all the vertices. So for example, if I were to draw a regular pentagon, which isn't quite perfect, but this is the center, just like a circle. So this length, this length, this length, this length, and this length are all equidistant. Okay? So now not only are all the sides, so now this one, Tori, like I'm tempted to call that a radius, right?
Yeah.
But it's not, because polygons and circles have their own snobby language, right? So we can't steal it.
Like I know, I was saying like I don't think it was a radius, but it's like a radius.
So this, yeah, you're right. So this guy, we would call that a central angle. Just like a central angle in a circle is just two radii that have the center as their vertex. This is a central angle. Okay. You guys know the measure of that angle? Can you figure out the measure of that angle? What is it? It's not. No. 360 degrees is a lot bigger than that. What's the measure of that central angle?
Oh, it's like 180.
Regular pentagon.
I don't know.
Is it 50 degrees? No. 40 degrees? 10 degrees?
I think I heard somebody say it, but
45. I said it 180. All right.
it's not 180.
Is it 20 degrees?
5.
No, how do you figure it out?
I have no idea.
My goodness, people.
I don't think I really figured it out.
180 divided by 5.
Wait.
What divided by 5?
360.
360 divided by 5.
Oh.
Because all the way around is 360, just like in a circle. But there are 5 angles here, and they're all congruent. Okay, so this is 360. The measure of the central angle equals 360 divided by 5, which is 72 degrees. Every angle is 72 degrees. In a regular, every central angle, well, not every central, but the central angle is just one of those pieces of the Trivial Pursuit thing there, right? Is it 5 or 6 in Trivial Pursuit?
I'm so sorry. Does that say 72 or 75?
72.
Okay.
Thank you.
Okay. Now, here's the deal. The central angle, so is the angle whose vertex is the center, the regular polygon whose sides pass through consecutive vertices. So there's only one central angle. So you can't make this bigger. So this is not a central angle. There's only one. Okay. Well, actually, there's only 5, but there's only one measure because it's not like in the circles where you can say this is a central angle. No, the central angle is the angle that connects 2 vertices. Okay. So see how the sides of the angle touch the 2 consecutive vertices. Okay. So now this guy, this line right here, this perpendicular line is a new term called the apothem. A-P-O-T-H-E-M. So the apothem is the perpendicular distance from the center of a regular polygon to a side is the apothem, okay? Distance from center perpendicular distance from center to side. And consequently, there's probably a theorem or property that says it's always going to go to the midpoint of that side, okay? If it's a regular polygon. So do you guys understand what the apothem is? So the apothem is kind of like the polygon's version of the radius. So apothem, radius, same thing, different languages, kind of like the metric system and the US customary system. They have their different terms. So far, so good? Okay, so now here's the deal. Technically, we have the information to be able to calculate this distance. If we know this distance, we can figure out, all right, well, that's half of that, and then figure out that. We could probably figure out the degree using trigonometry. We know this distance, and we know this one. Let's see here, that's 72 degrees, so half of that would be 36 degrees. So if we use trigonometry, we can figure out the length of that apothem, okay? But luckily, there's a nice little formula for you, okay? Most of the time. So here's the deal. The perimeter. Now, obviously, if you're given the perimeter, if you're given the number of sides and then the side length, you can find the perimeter. So n equals number of sides, and s is side length. Okay, obviously that's what we did, right? You can find the perimeter, just multiply the number of sides times the length of one side, and you got the perimeter, right? You all knew that. Okay, so here's the deal. I'm going to skip all those. So the area is a little different. Area equals, and write this formula down, you're going to need it, 1/2 AP. What's A stand for?
Area.
No.
Oh, it's
Huh? Apothem. That's right. And what's capital P stand for? Perimeter. So you have to figure out the perimeter. You have to figure out the apothem. Sometimes they give it to you. But then that's how you find the area. Now, think about it. If I were to find the area, well, how do you find the area of just one of these things here? Well, it's the length of one side times that height. Well, that height's the apothem. So here's 1/2 times base. Well, that's the base. The perimeter is just NS. So really that S. So if I just wanted to find the area of one of those trivial pursuit triangles there, then it's just 1/2 AS, right? 1/2 base times height. Well, the base is S and the height is A, the apothem. But if I wanted to find the whole area, then I multiply that by 5, which is N. So if you know the perimeter, you don't have to know the perimeter, figure out the perimeter to figure out this. You can just find, if you just know the length of one of the sides, then you just find the area of that triangle, which is 1/2 length of side times apothem, and then multiply it by however many sides there are, 5. But this is just the easiest way to write it, 1/2 AP, okay? Now, let's do an example. I want to find the area of this, let's see, what is that, an octagon? So find the area of this octagon. So let me draw the octagon. Okay, so let's say this is regular, even though it doesn't look very regular. So the way you know it's regular is if you have hash marks all around. And let's say that one side is 15 inches. Okay, and then they give us, yes?
How many sides are an octagon? 8, right?
8.
Okay,
Yeah.
I just want to.
So let's say the apothem is 18 inches. So it gives us the apothem. It's not in the diagram. It tells us what the apothem is. What's the area of this octagon? Go.
I'm going to use my calculator.
Wait, what does the small a stand for? Okay.
Stands for Apothem. So all you're doing is plugging in the information and chugging it out, right? So what'd you get? What'd you get? What'd you get? What'd you get? What'd you get?
No, wait, not that. Is it like a really, really high number?
No.
It is. Wait, I thought you would multiply 18 times 15 because of the, or is it the central angle?
You can multiply by 15. Well, you're gonna multiply by some 15 is gonna be in there. But what's the formula to find the area of a regular polygon?
Oh, I see where I messed up. Anyways.
Mm-hmm.
Okay, I got a really high number, but I'm pretty sure I did the formula.
What'd you get?
I got like 1080.
That's right.
Oh, okay.
That's right.
I was like, you said it wasn't a high number.
I know I didn't.
You see that? I was like, is there like a really high number? And they're like, no.
Did I? Sometimes I answer questions and I don't know what question
Yeah, I
I
think
answered.
you said no. Because I like did it. I just kept plugging it in. And I
Okay.
was like, this keeps appearing as my answer.
So I'm gonna just plug in 18 for A. Everybody okay with that?
Yeah.
And then what's the perimeter?
It's 8 times 15.
8 times 15, that's right. So let's see, 4 times 15 is 60, so 8 times
It's
15 is 120.
Oh.
So I'm gonna just go, all right, 9 times 120, which is 1080. Okay, and it's square inches, right?
Yeah.
Okay, all we did was plug it into our calculator and chug it out. Everybody okay with that? And if you want to understand why this is the formula, I mean, if you forgot this, you could probably figure it out by looking at this. Oh, because here's a triangle right here, and there's 8 of these all around. So if I find the area of this triangle, I just multiply by 8. That works. You don't have to use that formula. Well, finding the area of that triangle is base times height divided by 2. So see how I still multiply by a 15 and an 18, and then I divide it by 2, but then there's 8 of these, so that's where that 8 comes in. So you can figure out the area of that any way you want, but this just makes the formula a little bit easier. You just have to plug in your numbers and you're done, okay? Everybody okay with this? All right, let's see, what else do we got?
I feel like we're
Okay, now here's where it gets tricky. If it's tricky, if you would consider it tricky, I don't know if you would or not. But
assuming we're working backwards, trying we are given the area, trying to find perimeter or something.
well, no, it's here's the deal. I'm not going to give you the apothem. I'm just going to have you find the area of this regular hexagon.
Wait, but you're gonna help us find the area, but you're not gonna use the apothem?
Yep, find the area. And the only thing I'm going to give you is that this is 10 centimeters. Now, how the heck are you going to find the area of that?
So that's 60.
What did you say?
So I'm at 60 right now, because that's just the perimeter.
Oh, yeah.
So that's where I'm at now. So like half of that's, it's 30. So the area is 30 times A.
Yeah, so it'd be 30 times A. Now the trick is
Just find
trying
A.
to find A. Okay, if you can find A, then you're done, right? So equals 30A. So what the heck is A? How do you find A? Anybody know? Free problem set for anyone who can tell me how to find A.
I said like,
How to find the area?
no, the little A.
Oh, the little a.
Oh, wait.
What is the
Oh,
Five.
I know. Do I need to tell you the answer? How to
area?
Of course you do.
I know how to get it. Do I need to tell you the answer or how I'm going to get the answer?
If you can
Do both.
explain to me how to get it, then I will give you a free problem set.
You.
Oh, do you have your hand? What are you doing?
What does the little a stand for?
Apothem.
Oh,
So we want to find this length here because we have to know this to find the area. Okay, tell me how to find it.
We can divide 360 by, what is that, 6?
6. Yeah.
And then find the central angle. Is that what it's
Mhm.
called?
Yeah, I knew that.
And then from there we can figure out the rest, right?
Okay, how do you figure out the rest?
Oh,
So you got to tell me how to
Plug it
figure it
in.
out.
can I? Or is he can?
Yeah, you can take over if you want.
Okay, so like, because you have to find it, so it's 360 minus 6 or whatever, or divided by 6.
Divided by 6. So this is 60 degrees in here, this whole thing.
Oh,
Is 60, yeah. So if it's a 60-degree angle, then you just can do it like a squared plus b squared equals c squared. You can do it.
Okay, so what is the length of
So
this?
it's like, so since 60 degrees is c squared, right? No, never mind.
All right, Tobin?
I'm going to do it a very slow way. It's like it's going to work. I'm going to take 1/2 of the triangle, have it 30, 60, 90.
Yep, so this is
Figure
30,
out the
60.
area, figure out the area of one, and then times it by 2 to get the area of both triangles.
So how do you find the area of 1?
It's 30, 60, 90. So it would be radical 2 and then 2 times the short.
Okay, what's the length of one of the, what's this length?
5.
5. So those are 5s there. Okay, and what's this?
Would be 5 radical 3.
5 radical 3. Remember, that's the shortcut. So now we know the apothem. So now we can forget about the whole whatever you were doing, because we just found the apothem. So that's 10 as well.
360?
It's not.
I was gonna say, wait, isn't it 12?
So the apothem is 5 radical 3. Okay. So remember the shortcut to the 30-60 triangle? 30-60 right triangle. If this is 5, this one's going to be twice that, and this is going to be just tag on a radical 3. Do you remember doing that?
Yeah.
That's the shortcut. If you forget, you can use the Pythagorean theorem. So a squared plus b squared equals c squared. So you get 25 plus blank equals 100. So square root of 75 is 5 radical 3. So that's your apothem. So now you can multiply 30 times 5 radical 3. What's 30 times 5 radical 3?
150 radical 3.
150 radical 3. That's it.
It's not as satisfying.
Yeah, it's not very satisfying, but it's exact. Okay. So this was tricky, but this only works because now it could have worked. We could have used trigonometry to figure it out if it wasn't a hexagon. But since it's a hexagon, then these are all 30-60 triangles, which is nice. So you just have to remember, okay, it's just going to be half of this side times radical 3. That's what the apothem is. So if the side length of a hexagon is 10, the apothem is going to be 5 radical 3. If the length of the side of a hexagon was 18, what's the apothem? If one of the sides of a hexagon was 18 inches, what's the apothem?
This is not the answer.
Toby?
It would be 9 radical 3.
9 radical 3. So what are you going to say?
Question.
Yes.
So that whole blue triangle is a 60-degree angle.
Yeah,
right?
so this is an equilateral triangle. So that makes this 10, this 10, this 10.
Okay, but on the other hand, I thought it like, since it's a 60-degree, it has to be able to like solve. So if it's 10, it would have to be like the formula for solving the area of a triangle is like 1/2 base times height.
Yeah.
So you have the base of 10, and the height, would the height also be?
The height is the apothem.
But the height wouldn't be 10. But I don't know.
Yeah, so now,
It
so
feels like
this
the
little
base
guy,
was-
this is a 30-60 triangle. This is the equilateral triangle. That whole thing. But to find the area of the equilateral triangle, yeah, it's 10 times that. But you don't need to. The only thing that we're missing in this formula is the A. So you just have to find a way to figure out what the apothem is.
Okay.
So that was, oh look, if you draw the apothem, then you just drew a 30-60 right triangle.
Alright.
Okay, you can use the Pythagorean theorem to figure that out, or the shortcut, remember, is the short side times radical 3 is that long leg. Okay. So let's do one more. Okay.
One more example.
So
Pretty sure.
It's a lot. It's a lot to take in.
I don't think we like ever do 3 lessons.
Yeah, because I think the Thursday's lesson next week.
all right, I want you to find the area of this equilateral triangle.
This guitar is really getting to me.
Okay? Find the area of that equilateral triangle.
Six times A.
Wait, what are we solving for? Okay.
Find the area.
Okay. In radical form,
Yeah.
I forgot how to divide a radical, and I feel stupid. Can you just not do it?
Well, yeah, we can't. You can only divide a radical by another radical.
So would it be 81 radical 3 divided by 2?
No.
Okay, I have to. It's like.
Everybody got it?
I like. Anyways.
All the way. I have all of the measurements, and I can't figure out.
Okay, so keep working. Work silently. So if you guys get it, I will give you 2 Flack attack points. Okay?
I don't think that's right. Because I don't see it.
Not quite, but you got the right idea. Okay? That's not quite right.
That doesn't sound right.
You could do it either with the Apothem formula or you could do it your own way.
I think I can.
I'm like,
But this also doesn't sound right. I think I found it.
Yep. All right. Now hide it. Don't tell anybody.
Congratulations.
Thank you.
oh. Because you can. Okay, I might have it.
So you can either use those one of those 2 formulas. Okay?
Is it just.
Yeah.
No, not that.
Okay.
It's Oh, wait. Wait. I know how to solve this.
So in order to use one of these formulas, you either have to find the B and H or you have to find the A and P. Okay? So you can do it whatever way you want, but I'm going to show you both ways when we're done. So take another minute or so.
I might
See if
have
you
an
can get
answer.
it.
Is it?
So it's going to be in radical form
Wait, why is it
because
half base times height? It's an equal.
no, the base and the height are not the same. Just the sides are the same. The height of that is not the same as the
My,
side.
I'm I quit that. I was great.
Come on, you got it. You almost got it.
I'm all good.
Tristan, do you almost have it? You almost had it before. You're just. Which method do you use? Did you do the apothem or did you do just base times height?
I did the apothem.
Okay, so we'll do that way first.
Okay.
All right, if you can walk me through it, I'll give you 2 points, okay? So walk me through it. How do you do it with the apothem?
Oh,
What's the apothem look like? Right, like this, right?
yeah.
So that's the apothem, so that's what we need to find. Okay, so how did you do, what did you do to try to find it?
I just did 18 times 3.
Okay, so you had 18 times, so what'd you say, 3?
I don't actually know what I was doing.
That's all right. Well, you got close. You got pretty close. So 18 times 3 is the perimeter.
Yeah.
Yeah, so that's 54, right? 54. Okay, and then how did you find, what did you do to find the apothem? So let's clean this up and let's just make that 27 times A, right? So now we just have to figure out what A is. Because 1/2 times 54 is 27, so now we just have to figure out what A
I
is.
got that stuff.
Well, wait. I did it wrong.
Well, yeah, but what did you tell me what you did so we can kind of walk through it together?
I did it 9 radical 3.
Yeah, so you did 9 radical 3, but you went the wrong way.
Yeah.
Right? So this guy is this is the 30-60 triangle, but this time the 30 is over here and the 60 is over here. So this is the long leg. So what's the short, how do you get from the long leg to the short leg? You divide by radical 3. Okay, so what's 9 over radical 3? Have you remember the shortcut for that? Or so you have to get rid of that radical.
It's divided by 3 in the radical 3, right?
Yeah, so to get rid of that radical 3. So you get 9 radical 3 over, this cancels the 3. But then look, you can reduce the 9 and the 3 to what? 3 radical 3. So there's the apothem. 3 radical 3.
It's 3 times 27 radical 3.
Yep, so 81 radical 3. Okay, now let me show you the base times height way. If I did it the base times height way, I need to find the height. Well, look at the height. The height is a 30-60 triangle. So if this is 9, this is 9 radical 3, right? So 1/2 base times height is 1/2 base is 18. And then the height is 9 radical 3. So 1/2 times 18 is 9, times 9 is 81 radical 3. Okay, so with an equilateral triangle, there's multiple ways you can do it because, you know, it's just a triangle. So how do you find the area of a triangle? You need the base, which is 18, and then the height. So that if you don't do it the shortcut way, guys, you can just use the Pythagorean theorem. To find the height, you cut that in half. So there's 9, 18. Pythagorean theorem says a squared plus b squared equals c squared. Okay? So 18 squared is like, what is that? 18 squared, something big. Minus 81 squared would be that. Okay, then you take the square root of that. All right, that's it. That's all I got.
Black math, give me some math and I'll give you some flack. Black math.